Here in this video, I will explain you the drawbacks of Rutherford's atomic model. According to Rutherford's model, nucleus is having positive charge and electrons are revolving around the nucleus. Now, what is the direction of the velocity at this position? This one is the direction of velocity. Right. Now, at here, what is the direction of velocity? This one. At here, what is the direction of velocity? This one. What is here? This one. Now, we know a term called acceleration. What is that? dv by dt. That is change in velocity with respect to time. Is there change in velocity? Yes. But is it due to magnitude? No. Let's say the magnitude is 5 meters per second, for example. That is the same. The value doesn't change, but the direction changes. Now, our velocity has both magnitude and direction. Now, when the direction changes, I can say that the particle has now got an acceleration. What is that acceleration? That is centripetal acceleration, v square by r. But anyway, it is having an acceleration. According to classical electromagnetic theory or Maxwell's theories, Maxwell theory, an accelerated particles emits radiation. So when a particle, it's not all accelerated particle, as accelerated charges or charged particles. So I'm going to take it as charged particles. Now, when we have a charged particle accelerating, that will emit radiation. Now, radiation is nothing but a form of energy, right? Now, when a particle emits radiation, certain part of the energy has been radiated out. Now, what is the energy after that? Then initial energy minus the energy of the radiation. So, if radiation is having a frequency of mu, the total energy is h mu. Now, if initial energy is E, what is remaining? E minus h mu is remaining with electron. So, according to Maxwell theory, accelerated charged particle will emit radiation. Now, according to Maxwell, according to this, we know that this one, E, it's an electron. Electron is a charged particle. First condition is right. Now, what is the second condition? It has to be accelerated. If it is moving with constant speed or constant velocity, not constant speed, constant velocity, no problem. If an electron is moving in this direction with a constant velocity or without changing its speed in one direction, then it is a non-accelerated particle. Now, the moment it changes its direction, it is an accelerated particle. Or if it is speeding up, then it is an accelerated particle. Now, with this theory, when we are comparing, then this is an accelerated charged particle. According to Maxwell, Maxwell has proven this theory with experiment. It have to radiate energy. Now, if this is radiating energy, what will happen? After energy being radiated, that will occupy a lower radius. Okay, as when the energy comes lower and lower and lower, reduces to a small value, what will happen? The electrons will come closer to the nucleus. The outermost electron has got highest energy. Now, innermost electron has got lowest energy. Now, from this, whenever it emits radiation, it will come closer and closer and closer. Finally, that will collapse with nucleus. The nucleus positive charge, electron negative charge, that will be collapsed. Now, the entire atom will be collapsed. For this, it will take 10 power minus 8 seconds. Not even 1 second. Now, if this one is true, every atom will collapse the moment it has taken birth. But it is not happening. All atoms are stable, right? So, with this theory, he was not able to explain the stability of an atom. According to his theory, according to Rutherford model, the atom is unstable. That electrons will finally bombard with nucleus and that will be collapsed. The whole atom will be collapsed, because when there is no electrons and nucleus, then there is no atom. First thing is very clear. Next thing is he cannot explain the discrete spectra of atom. Spectra anyway we will learn in next lecture, but I will tell you what is spectra. Now I have told you the innermost orbit has got lower energy and outermost has got higher energy. Let's say this is nucleus. Now we have other orbits as well. Now when an electron goes from one orbit to other orbit, that will accept energy. From here, that will accept energy and go to another outer orbit. Here it will accept energy and go to outer orbit. According to Rutherford, he hasn't told anything about this orbit. According to him, one electron can revolve at here. Let's say having in first orbit. Now let's say we have a second orbit. For example, in between first and second orbit, according to Rutherford, there can be one more orbit. There is no limit where an electron can revolve. If an electron wants to revolve here, it is possible. If it has to revolve here, that is possible. If it has to revolve here, that is possible. Now how to move from here to here? By accepting energy. From here to here, by accepting energy. And even if it is getting a small energy increment, then that will go to a higher orbit. A small energy, higher orbit. A small energy, higher orbit. Now electron can revolve anywhere across around the nucleus as per Rutherford model. Now if that is possible, if that is true, then we can expect a continuous spectra. But actually when we analyze spectrum, then that is discrete spectra. I will give you a small introduction about that. Discrete spectra means, let's say we have an atom here, and that is a nucleus. So from this is third orbit, second orbit, first orbit. Now from third orbit, if it is coming to second orbit, let's say first orbit is associated with an energy of, these all are examples, okay. To the true values, actual values we will see in the coming lectures. So first orbit, lower energy, let's say 25 joule, 50 joule here, 100 joule here. Now how to move an electron from 100 joule to 50 joule? By emitting a radiation of 50 joule. Now from 50 to 25 joule, how it can come? By emitting a radiation of 25 joule. Now how it can come directly from 100 to 25? By emitting a radiation of 100 to 75, 25, by emitting 75 joule. Now let's say an electron from 100 joule, it has only three possibilities. One is 100 to 50, it can come by emitting 50 joule. Then from 50 it can go to 25, emitting more 25 joule. So these are two possibilities. One more possibility, it can go straight away from third to first by emitting 75 joules. Now when we are seeing the emitted radiation, one should have 25 joule, other should have 50 joule, and other should have 75 joule. There should not be any other energy possible. I mean any other radiations with any other value of energy possible. Let's say if it is emitting 30 joule, where it will go 100 minus 30, it is 70. But we don't have an orbit with 70 joules here. We have with 25. So 100, if it gives out 75, it will go to 25. But if it is giving out 30, there should be an orbit with 70 joule. We don't have here, right? The only possibility is giving out 50 and go to 50, the orbit having 50 joule energy. If it is giving 20 joule, then it should go to the orbit having 80 joule. But is there an orbit having 80 joule? No. So this is the actual atom which is proposed by Bohr. We will anyway get more details about it. According to Rutherford, he has told that from 100 joule, it can go to 99 joule by emitting 1 joule of energy. Then from 100 joule, it can go to 98 by emitting 2 joule of energy. 97, 3 joule of energy. But with experiment, what we have seen here is, here with the example, only 3 radiations are possible, 75, 50 and 25, as I have explained to you. But according to Rutherford, anything can be possible. Let's say from 100, if it is giving out 0.1, then it will go to a new orbit having 99.9 joule. If it is giving 0.2, then 99.8 joule. So all radiations is possible from an excited atom. But with experiment, we were only able to see discrete spectra, which means only certain wavelengths we are able to see. If Rutherford is right, every wavelength we are able to see. So that is the meaning of this one. So anyway, these values are just random numbers. Don't learn this thing. I have just explained it with this example just to deliver you the concept about spectra. We will go into detail. Okay. Thank you.